Think of a web API, which is an application programming interface, as a set of rules and protocols that allow different software applications to communicate and exchange data with each other over the internet. Just like a waiter in a restaurant takes your order and brings back your food, which is a form of a request and a response, a web API allows one application to request specific data or functionality from another web application, which would be the server. With APIs, developers can leverage existing functionalities and data from other services without having to build everything from scratch. For example, your website can use Google Maps API to embed a map instead of building its own mapping system. They also allow for different systems and platforms to work together seamlessly. Think about a social media app that lets you share a song you're listening to on Spotify, for example. That's likely done through APIs. APIs allow applications to communicate regardless of the underlying technology they are built with. So, a mobile app, for example, built with Swift or Kotlin, can fetch data from a web server built with Python or Node.js through a well defined API. And modern applications are often built as a collection of small independent services that communicate via API, making them more scalable and maintainable. The most common type of API that we use is the RESTful API. I should say that we encounter, not that we what we use. So the RESTful API, and here is a simplified overview of how it works. A client makes a request, an application, the client, example your web browser or a mobile app, sends a request to a specific URL, the API endpoint on a server. This request specifies what data or action the client wants. Common request methods include get, post, put, delete. So these are the request side, the client side. Then we have the server side, which processes the request. The server receives the request, processes it, and performs the requested action. For example, retrieving data from a database. Then the server sends a response. So it sends a response to the client, and which typically includes a status code which indicates the outcome of the request. For example, 200 OK or 404 not found. And it includes a data body and the actual information requested, often in a structured format like JSON, JavaScript object notation, or XML extensible markup language. So this is about the body of the information that has been requested, and the server will send, will include. So let's give an example for that. If a weather app, for example, wants to get the current temperature for Beirut, it might send a GET request to a weather API endpoint like Open Weather Map, for example, and the server would then respond with JSON data containing the temperature, humidity, and other weather information. The RESTful API is an acronym, so let's state what it is. It's the Representational State Transfer Application Programming Interface. It is an architectural style for designing networked application. It relies on a stateless client-server communication protocol, typically HTTP. Uh, they use standard HTTP methods like get, post, put, delete to perform operations on resources, which are identified by URLs. Data is often exchanged in JSON or XML formats. The key principles include statelessness, which means that each request from a client to the server contains all the information needed to understand the request. And it has to be resource based, which means that everything is treated as a resource. And the use of HTTP methods for actions. Let's now discuss the API that is the topic of this course, which is the Attribution Reporting API. It is a set of browser APIs designed to help advertisers measure when ads lead to conversions, like purchases or signups, in a privacy-preserving way. So this is the most important thing because we already have cookies, and cookies do almost the same thing, but without the privacy aspect. So the attribution reporting API addresses the growing need for conversion management while limiting the tracking of individual users across the web. So it was created because traditional conversion tracking methods often rely on third-party cookies, which can track users across different websites. This raises significant privacy concerns, and the attribution reporting API aims to provide a privacy-centric alternative, and it does that by aggregating the data by processing on the device, so performing much of the attribution processing within the user's browsers. So how does it work? There's an ad interaction, first of all. So a user interacts with an ad, for example, clicks or views it, and the browser records this event. Then there's the conversion event, which is if the user completes a conversion on the advertiser's website, the browser records this event as well, if it actually converts. And conversion can be measured however we want to measure it. So, and then there's the privacy preserving reporting aspect of it. The browser generates reports that link the ad interaction to the conversion, but in a way that protects user privacy. This can involve techniques like aggregated reports, differential privacy, or limited information. It's also worthy to add here that with this API, we can get two types of reports. So we can get an entry level report or a summary report. So one is aggregated, the other is granular and detailed. Understanding the attribution reporting API is increasingly important for students nowadays, especially if they're interested in web development, because the web is evolving towards greater privacy, and developers need to understand and implement these new APIs for advertising and analytics. Um, this is also because there's a fundamental shift on online advertising and the effectiveness and how it's measured. So, future marketers and tech professionals will need to understand the principles of this API to be able to read into their conversions in a modern marketplace. There's the obvious and the most important issue of privacy and security. Studying this API provides insights into how technology can be designed to balance the needs of advertising with user privacy. So, by learning the attribution reporting API, students will gain a forward looking perspective on the future of web measurement and develop skills relevant to the evolving digital landscape. Let's take an example. Let's look at this graph, and it shows an online shop. Let's say we have an online shop, call it shop.example, aka the advertiser, and it embeds an ad for one of its products on a content site calling, let's call it news.example, which is the publisher, and the ad content itself is found at an ad.shop.example. So this is where we get the content for the ad. The online shop owners want to measure how many conversions they get from users interacting with the ad, viewing the product page on their site, and putting the product into their shopping cart. So let's break down the process of the attribution reporting API step by step and how it works here. So step one, tracking the initial ad interaction on the publisher's site. So imagine the user browsing the website, a user browsing the website, and he finds our page, and embedded within our page is the advertisement for this product sold on a different website, shop.example. The attribution reporting API begins its work when the user interacts with this embedded ad in some way. So this is the beginning, the first interaction with the embedded ad. The API starts its work. Not every interaction automatically triggers the tracking process. For the API to start recording this ad interaction as a potential source of a future conversion, a specific mechanism needs to be in place. When the user engages with the ad, perhaps by clicking the link, for example, the code associated with that ad can initiate a network request. This request is special because it includes a particular signal, the attribution reporting eligible header. Now, the word header is very important whenever we're talking about APIs. This header acts like a flag telling the user's browser that this specific interaction is something the advertiser wants to track for potential future conversions. So, this is how we manipulate the mechanism of tracking. The browser then looks at the server's response to this request. If the server's response includes another specific header, the attribution reporting register source, it means the advertiser's server agrees that this interaction should be recorded as an attribution source. This header also contains instruction and data about the ad interaction itself. So think of the attribution source as the initial touch point. The moment the user saw and clicked the ad, the data registered with the source will later be used to determine if this ad interaction eventually led to a conversion. So step one was the tracking of the initial ad interaction on the publisher's site. So now we move to step two. Or tell you what, before we move to step two, let us take some concrete examples on how attribution source can be registered based on different user interactions. So all in step one, in the tracking, still in the tracking. Let's say there's a link click. If an ad is a clickable link created using an HTML anchor tag or triggered by JavaScript's Windows.open function, the act of the user clicking the link is the interaction. When the browser sends the request to navigate to the new page, presumably the advertiser's site or the landing page, the server hosting that initial ad link can include the attribution reporting register source header in its response. So this registers the click as an attribution source. We can also get the same with an image impression or a fetch request. So we move to step two, which is storing the initial interaction data securely. Once an attribution source is registered, meaning the browser received a response with the attribution header, which is the attribution reporting register source header, the browser takes the data provided in this header and stores it in a private, isolated storage area on the user's device. This storage is crucial because it's designed to protect the user's privacy. So only the browser itself has access to this cache. Let's move to step three now. So step three is tracking the conversion events on the advertiser's site. So later, if the user, perhaps influenced by the ad they saw on news.example in our graph above, visits the advertiser's website, shop.example, the API continues its work. When the user performs an action on shop.example that the advertiser considers a conversion, for instance, clicking add to cart button, completing the purchase, the shop.example website can initiate the registration of an attribution trigger. All right, so if a conversion is detected, an attribution trigger is registered. Similar to the source registration, the uh, the attribution trigger involves the website sending the request with the attribution reporting eligible header, uh, and if the server on shop.example, which is the website, determines that this user action qualifies as a conversion event and they want to track, it will respond with a uh, attribution reporting register trigger header. So this is the response header, and this header contains data about the conversion event itself. Just like with attribution sources, attribution triggers can be registered through various mechanisms. So they can be an image load when a user completes a purchase. The website might load a shopping cart icon, for example. But the most important thing is that it is the we have attribution sources and attribution triggers now. Or an example on the trigger part, which is the response basically to the first request. So let's say an add to cart button triggers a JavaScript fetch function, for example, or an XML HTTP request to update the shopping cart. The server handling that request can include the attribution reporting register trigger header in its response, indicating that an item was added to the cart. So it's all about these headers. And now we can move to step 4, which is matching the conversion to the initial ad interaction. Step 4, matching the conversion to the initial ad interaction. Once an attribution trigger is successfully registered on shop.example, the browser's internal logic kicks in. It looks at the data contained in the attribution reporting register trigger header and attempts to find a matching attribution source event that was previously stored in its private local cache. The API has specific rules and methodologies for determining if the trigger event matches a source event. So these rules take into account factors like the destination of the source, was the ad on the website that expected conversions, and potentially other criteria defined in the source and the trigger registration headers. Then step 5, generating and sending privacy preserving conversion reports. If the browser finds a matching attribution source for the registered trigger, it generates a conversion report. This report contains information linking the initial ad interaction to the subsequent conversion. Crucially, this report is sent to a specific endpoint on a reporting server, typically owned and operated by the ad technology provider that facilitated the initial ad display. A key privacy feature here is that the conversion data is only sent to the designated reporting server. Unlike third-party cookies, this data is not broadly shared and nor given to multiple websites or numerous other parties. The attribution reporting API offers different types of reports, each with its own level of detail and privacy considerations. They range from entry-level reports to really detailed and granular reports. So remember, registering the attribution sources, registering the attribution triggers, and then generating reports. And these are the all important HTTP headers. We have the reporting eligible header, the attribution reporting register source header, and the attribution reporting register trigger header.